guys, my name is Fateh Shazwani binti Zurimi. Firstly, before we go through to the topic related rates, we must know that related rates question are correlate with derivative. Introduction. What is derivative? Derivative is a function of a real variable measures the sensitivity to change of the function value, which is output value, with respect to a change in its argument, which is input value. Derivative has many applications, especially in mathematics, science, engineering, and also physics. Related rates is one of subtopic in application of differentiation. Related rates. Related rates problem involve two or more variables that change at the same time, possibly at different times. Related rates problem also deals with quantities or variable which increase or decrease with respect to the time. The expression of rate of change with respect to the time is dv over dt. Related rates also involve basic solid figures. For example, cube, cylinders, cone, sphere, and also hemisphere. Step of solving problems. There are 5 steps of solving the related rates question. Step 1. Read the question carefully. Draw the diagram if possible and define the suitable formula. Step 2. Write an equation that relates the various quantity of the problem. Step 3. Differentiate implicit both sides of the equation respect to time or using change rule. Step 4. Substitute the known or given rate of change and the known quantities into the construct equation. Step 5 or final step. Solve the equation for the rate of change to be computed.
Now we understand what has been described earlier. So what does the related rate have to do with our daily life? What are the applications of differentiation in our daily life? So let's begin. I will show you things that we can relate to this application, which is related rate. Let's say I have 5 meters of steel to make the contours of a pipe that is half around. We now want to know how we could use these 5 meters of steel to create the most amount of frontal area. But we have a limitation. The metal has to be shaped into 2 equal parts and 1 other part. They must be straight. We don't have the money to shape them any other way. So what we can do is we can only cut them. That means that the 2 equal parts will make an angle with the other parts to form the pipe. What is the best angle to place the 2 equal pipe at? This problem comes directly from the real world. Maybe some more limitations, but in the real world, it's all about efficiency. And that is why calculus and differentiation in this case is super important.
Example question. An ice cube melt uniformly where the volume decreased by 3 cm cube per second. And how fast is the surface area decreasing when the cube edge is 5 cm? To solve the problem, Step 1, we look at the picture, variable and formula. As we can see, volume of a cube, which is V, equal to x cube, and surface area of a cube, which is SE, equal to 6x to the power of 2. Next step, which is substitute given information. We need to find how fast the surface area is moving with respect to time. So we already have the volume of degrees, which is 3 centimeter cube per second, x equal to 5 centimeter, and the volume is 125 centimeter cube. So we substitute in x equal to square root 3v, then we get SE equal to 6 square root 3v cube. To solve the problem, we need to find dSA over dt, which is SA equal to 6v to the power of 2 over 3. So with dSA over dt equals to 4v to the power of negative 1 over 3 dv dt. And we substitute the volume and the dv dt, which is 125 and negative 3 centimeter cube per second, and the answer is negative 12 over 5 centimeter cube per second. We also can check for the reasonable for the answer that we get.